first part of this series, where we'll take the first question and by so doing, look into scalar multiplication in matrices. So the first question says that we should find matrix D such that D is equal to 5A. And our matrix A was given as follows. So what is scalar multiplication? Well, this involves multiplying all elements of a matrix by a single value. So let's take an illustration, assuming matrix X is equal to this. If asked to find minus 3x, that means our scalar is minus 3. That is the number before the matrix. So we multiply all the elements in the matrix by minus 3. Take note that your scalar can be any positive or negative number or even a fraction. So mathematically, we write this by taking x and placing the scalar, which is minus 3, before it like this. Then we multiply a, b, c, and d each with the scalar, and this will give us a final result. The exact same thing happens with the actual question. We take matrix A and place 5 before it to express the scalar multiplication mathematically. Then we multiply all the elements, in this case 5, 1, 3, and 6 by 5. That leads us to our final answer as this, which is also equal to D. Now, generally in matrices, there are some things you should note. The first thing is that matrices are identified by their dimensions. What I mean by this is that when you see a 2 by 3 matrix, usually written as 2 times 3, the number before the multiplication sign represents the number of rows, while the number after the multiplication sign represents the number of columns. So it's written in the row by column format. Always remember that rows go in the horizontal direction from left to right, and columns go in the vertical direction from top to bottom. So if you see a 1 by 3 matrix, we know that it has 1 row and 3 columns. With this row by column format, we can make a distinction between a square and non-square matrix. So just think about a square shape. Its major property is having its length and breadth to be equal. So also the number of rows has to be equal to the number of columns in a square matrix. But when the number of rows and columns are not equal, we have what is called a non-square matrix. Now, there are some operations that can only be performed on square matrices, but we'll learn about that in subsequent videos. For now, I hope you gained something, so let's move on to the next part of this series.